Well, hi everyone. I think I have a nice treat for you all today. I was surprised that Wyoming DOT hasn't really provided many updates about their rebuild of the main embankment section of the roadway next to the portion that it failed earlier this year in June. They released one picture in mid-August. It indicated that they were starting the soil nail installation. So I commissioned my own drone flight. It flew on Tuesday, September 9th. I'm recording this video on Thursday, September 12th. So I'm going to go through this footage. Also through my anonymous source, I've got a copy of the baseline geotechnical report that was issued relative to the design and construction of that temporary bypass. And I found that report to be rather revealing and quite concerning still. It doesn't allay any of my concerns about whether they had enough information to provide an adequate factor of safety in their analysis. You know, initially when this happened, I was concerned about whether WyDOT would have enough information with which to base a design and ensure its safety for a reconstructed section of the roadway for this bypass section. So we'll go through that as well. So let's start by looking at the drone footage. That darker brown area is the steepened slope that has been stabilized with soil nails. There's a mesh going over the slope and cables connecting these various anchors, and they're working from a top-down fashion. So right now we're looking to the south, and it's going along rather well. Ames Construction is the prime contractor on this main embankment reconstruction. Keller is installing the soil nails, and I understand they'll be installing micropiles later on. I'll go over that here in a minute. So now we're moving to the north. You can also see, we'll have closer images of it, but they're processing some of the fill from the downslope side to the other side of the slope. These are just great shots. I'm very pleased with the results of this footage. You can see that they've got a relatively small area in which to work. The original failure covered a length of 200 feet and involved both roadway lanes sliding off down the hill. But you can see in the foreground they're processing some of this material from the old fill. I don't see a discharge conveyor. So what they're doing is they're excavating this material, they're putting it in a hopper. It feeds over to the top of a screen called a grizzly. And then that material, the resulting material, it drops out, ends up on a conveyor, and I'll show you what they do with that here in a moment. Okay, you can see some of their support equipment, large water tank. This is the material coming off the top of the conveyor. They're taking a front loader, loading the dump trucks. The dump trucks cross Highway 22 and in-dump the material for later use on the other side of the roadway. So you can see him getting ready to cross the road here. They're just waiting for a gap in traffic. Okay, so now he's coming down the other side. This is a return truck. So great footage. I'm very pleased with it. So WyDOT had a presentation back in July at the local library, and they showed this cross-section of what the redesigned embankment is going to look like. So the gray area is going to be the replacement fill, and I understand it's going to consist of styrofoam blocks, lower density material, so that there's less load placed on the foundation soils once the embankment's reconstructed. They'll also have soil nails for that temporary oversteepened slope. Soil nails are really just to facilitate construction. They're not going to provide any overall improvement for global stability. And at the base of this new fill section, they're going to have micropile to provide increased shear resistance for potential failure surface of the embankment. And then that's going to connect to some drainage material at the top, trying to intercept that water. So here it is, the baseline geotechnical report issued August 23rd, 2024. Keep in mind that this roadway, this temporary bypass as they're calling it, was reopened to traffic on June 28th. So I want to go through some of the key things that I've noticed in this report. So as I've mentioned in previous videos, I was concerned all along as to whether WyDOT would have sufficient time to do a full geotechnical investigation, have enough time for analysis before they essentially rushed to reopen this road to traffic. As a recap, this is a summary of the failure. A motorcyclist crashed on June 6th, which tipped them off that there was cracking and movement of the roadway, and then it cut loose altogether on Friday, June 7th, or early morning Saturday, June 8th. And this is what it looked like. Now, these are the boring locations. They had 2 previous borings, and then they did 12 additional borings subsequent to this failure to better characterize the subsurface and embankment soils. That's what that says here on June 10th. So a couple days after the failure, they got started with their field investigation. But all they did was collect split spoon samples. Those are disturbed samples. But surprisingly, they didn't collect any Shelby tube samples. There are clay zones that don't contain gravel near the base of this embankment that would have been very good candidates for taking undisturbed samples to facilitate high-end laboratory testing to assist with the analysis of the overall slope stability. So as I mentioned in my most recent video on this project, WyDOT contracted with RJ Engineering Consulting out of Evergreen, Colorado to do the slope stability analysis. And their analysis was included in this baseline geotechnical report. So their slope stability analysis report was issued June 28th, 2024, which is the day that WyDOT opened this bypass to traffic. And as I mentioned in the previous video, the thing that really jumped out at me is that they assumed soil parameters for use in their analysis. They said soil parameters were mutually agreed upon with the design team for the stability analysis. And they don't present what soil properties, what strength values that they actually used in their analysis, which I thought was quite unusual. That every slope stability analysis report that I've ever seen or have ever written includes a discussion of the shear strength parameters that were selected for the analysis, because without reasonable or appropriate values, the analysis doesn't mean much. So this shows you the boring locations. They ended up taking some split spoon samples in boring 24-02 and combined them and performed direct shear tests. So I'll cover that here in a second. As I go through this, there's really kind of 2 audiences here. The geotechnical engineers, and I know there's many of you who watch this channel on a regular basis, we'll get some of the details that I'm looking at here, but I'll summarize it in a more broad fashion to indicate what the implication is of these details. So this boring that was used to collect the SPT samples that were later used for direct shear testing, 2402, was drilled and completed on June 11th. So samples 12 and 13 were at approximate depth of 38 and 43 feet. We can see we're in a fat clay, 15 to 27 blows per foot for the SPT value. The material is described as light gray to bluish white, stiff, slightly moist to moist, very uniform. Again, that material could have readily been sampled with a Shelby tube sampler, which is a more undisturbed specimen that you would use for a high quality test. You don't use or want to use lower quality samples for high quality tests. So this is the results of their direct shear tests on these remolded samples. And remolded samples can provide lower bound strength values, but again, I would think that you would want to confirm the results with other laboratory testing on high-end samples, Shelby tube samples, or there's other methodologies for collecting undisturbed samples that are used for high-end laboratory tests like triaxial shear tests, both drained and undrained. And I think that would have been a key thing to have done here. But they label this as figure 6/25/24, which looks a lot like a date, June 25th, 2024. So that's only 3 days before they reopen the road to traffic. But more importantly, there's no discussion in the slope stability analysis report that they even utilize these results. So let's cover another aspect of how you would model the slope for stability analysis if you have very limited subsurface information about the nature of the soils. So these yellow and blue lines show their cross sections that they analyzed. So what they did was a post-failure analysis. And that's where it's called a back analysis, where you estimate values for shear strength, cohesion, angle of internal friction. You estimate the level of the groundwater or the piezometric surface, and that's used to calculate the effective stresses at your trial shear surface or your actual shear surface. And then you have to understand what the unit weight of the soil is, its density, and that factors into both driving and resisting forces due to gravity for the material being in place. And then obviously you have to accurately model the configuration of the slope and characterize the location of the various soil layers or different material that was used to construct the embankment in the slope stability analysis model. So after you've done this back analysis, you iterate or you vary these values until you get a factor of safety of 1.0 in your model. And then you use that same set of assumed values for all those things that I talked about to do a forward analysis of your reconfigured slope after you've rebuilt the roadway in this case. Now there's an excellent text on soil strength and slope stability by Duncan, Wright, and Brandon. And it's interesting, you see in the title, soil strength and slope stability get equal billing here, because without adequate soil strength values, slope stability analysis again is meaningless. But in this text, they caution about some of the limitations with this back analysis methodology, because in essence, the results could be non-conservative. In other words, you could think that you have a better situation when in fact you may not for going forward on a project. So I'm just going to read these really quick. Back calculated shear strengths must be used cautiously if progressive failure has occurred. Second point, laboratory data and experience can provide useful information to guide the back calculation of shear strengths. Even when laboratory data are not available, it is possible to make reasonable estimates of the friction angle based on index properties. If the shear strengths are decreasing significantly at the time of failure due either to changes in pore water pressure or softening of the soil structure, the back calculated shear strengths may not be appropriate for use in designing remedial measures. It is important to assume the appropriate model to back calculate the shear strength parameters. Curved Moore failure surfaces and anisotropy may influence the validity of back calculated shear strengths. So again, a lot of caution here. They also mention in the text that three-dimensional effects should be considered as well. So bottom line, it's not the most conservative way to go. It would be appropriate to supplement what you assumed in a back analysis method with some laboratory test results of high quality samples using high-end tests. And that wasn't done here apparently. So what does this all mean? The slope stability analysis that was performed based on whatever information they used or generated from their analysis, resulted in an overall factor of safety of 1.2. And as I've mentioned in previous videos, I thought the minimum factor of safety should be 1.5, and I still believe that. So I have, my concerns about this have only deepened after getting a copy of this report. Again, I just read through what the limitations can be for a back analysis methodology. The direct shear testing that they did on remolded samples, apparently those tests were performed just a few days before they reopened the bypass to traffic. But again, the slope stability analysis report doesn't indicate whether they even utilize those results of the direct shear tests. So I've shown this before. This comes out of Federal Highway Administration Guide for Designing Highway Embankments. And I'll just read this again. For slope stability analysis of significant fill slopes, and I would consider this significant at over 70 feet, the desired minimum safety factor, FS, is typically in the order of 1.3 to 1.5, depending on the levels of importance and risk and the uncertainty in the slope analysis input parameters. Well, if you're assuming soil parameters or you're generating them based on back analysis, I think there's potential for a high degree of uncertainty in the soil parameters. So again, I don't understand how in any way WyDOT can support a 1.2 factor safety when this road's been reopened to traffic. And again, one of the key aspects as to why the analysis may not be conservative, in other words, you may not be as safe as you think, or WyDOT in this case, is that you may not have a understanding of the actual soil strength values or the variation of the soil strength values throughout a potential shear surface of the embankment. You may not have a handle on groundwater conditions that at the time of the analysis or subsequent to that. So again, in the close of this analysis report, based on our understanding of the project data provided to us and the current estimated groundwater levels, we offer the following. RJ has provided what we consider are the two critical analyzed sections. The detour template is at a factor of safety of greater than 1.2 for the current slope and water conditions. Headscarp slopes may be at a factor of safety of less than 1.2, but the factor of safety between the slope face and the current detour roadway is greater than 1.2. And of course, they're talking about the monitoring system that they have in place for the embankment. So there was another interesting bit of information in this baseline geotechnical report. Going back to the time just before the failure, I had previously commented that I didn't understand how WyDOT didn't appreciate that this whole embankment was going to cut loose. You see the cracks in the roadway. And one of the things that WyDOT mentioned is in the inclinometer readings in May of 2023, those were the most recent readings they had prior to the big embankment failure, that there was virtually no movement. And I thought, well, you know, why didn't they measure that inclinometer in June when they saw these cracks open up in the roadway? Well, from this baseline geotechnical report, we now know it was because that inclinometer casing had sheared at a depth of 70 feet. So within the embankment soils. That should have been a big clue that this embankment was going to fail. If you went from essentially no movement in May to a sheared off inclinometer in June, that's very troubling. Yet WyDOT didn't close the roadway for that purpose. They closed it due to a mud flow a couple miles away. And then they also proceeded to put construction crews out there to remove the asphalt paving to reduce the driving forces of this slope going downhill. And I mean, that's absolutely futile. It's such a negligible amount of material, and you're actually adding more load in a localized area with the construction equipment being used to remove the asphalt. So it boggles my mind that they would do that. So there it is, I've laid it out. You could see this baseline geotechnical report. The samples they collected were SPT samples. They used remolded samples to do direct shear tests, for a handful of direct shear tests, and it's not clear whether they use those direct shear test results in any fashion to verify their slope stability analysis. And the type of slope stability analysis that was apparently done utilizing back calculated values from the geometry of the failure surface can be quite unconservative. So the slope could be at a higher risk of failure than what would otherwise be thought. So I know there's lots of geotechnical engineers out there. I know there's some of them in Wyoming that they reached out to me early on and thought I wasn't being fair about my concerns or frankly my criticisms about the rapid pace of the reconstruction of this bypass roadway. So I'd like to know what you think now, given the information that I've presented from WyDOT's baseline geotechnical report. To me, this is very troubling, and I have contended all along that there shouldn't be traffic on this roadway to allow the crews unfettered access to do a reconstruction for the overall embankment. And now they've got their work cut out for them because WyDOT took over 2 months to award the contract for the reconstruction of the main embankment. So as it stands right now, looks like they're pretty close on getting to the bottom of the excavation and installing their soil nail system, but they've got to put the micropiles in, all their drainage material, and all the backfill to restore the embankment. And I think they have maybe 6 weeks to do that. That's going to be a tall order. So let me know what you think out there. I'm going to show more drone footage at the end of this video. But first, I'd like to send a shout out to those of you who are channel members. That's a great way to support the channel. I really appreciate it. As well as those of you who have provided super thanks. I'm going to roll those credits here, and then at the end of that, I'm going to show this additional drone footage. So please let me know what you think about this. I think it's really exciting drone footage, and I'm glad to be able to bring this to you. So thanks very much, everyone.